Welcome to part 1 of ECAD VLSI lab. In this session, we are going to discuss the basic terminologies of ECAD VLSI, what are the different types of an integration levels and what is meant by a circuit and what we are going to see in this particular laboratory. Okay, you know already in your past semesters or previous semesters you will have an idea of an LST. Okay, there you will be seeing all the different kinds of combinational circuits, sequential circuits, and you will be knowing what are the different types of passive circuit. Passive components, active components, and what are their characteristics and everything. Okay, now let me have a small introduction of those circuits and let us see the in-depth of what is meant by an ECAD, VLSI and different what is the link between an ECAD and VLSI. So first of all, VLSI is denoted as very large scale integrated circuit. IC is nothing but integrated circuit. Now what is meant by a circuit? A circuit is nothing but it consists of all the active components and passive components together, and it is interconnected and giving some input voltage from your functional generator and checking the output waveform with the help of an CRO or whatever it may be. And those all components will be placed on a breadboard. Okay, either breadboard or an PCB board or whatever it may be. That is nothing but a circuit. And integrated circuit means that is nothing but what are the different components, like whatever your resistors, capacitors, inductors, even transistors, and all those are, because each and every component they will have their own functionality feature. By connecting all the different components together is nothing but an integrated circuit. Means you are doing an different functionality features you are combining together and making as a single circuit. All those components will be placed in a single IC. Okay, now how the integration? Now you are saying integration is nothing but combining of all the components. You are saying how many number of components to be present in that. In this different components, all these resistors, capacitors and inductors are very small amount of components, so it will be of 2 or 3 inductors, capacitors and resistors will be placed. But major components on an IC is nothing but your transistor count. Okay, depends upon the transistor count only the integration levels will be changed. Now what are the different levels of an integration? The first one is SSI, small scale integration. Small scale integration is nothing but consists of 10 to 100 number of transistors on a single IC is nothing but small scale integration. The next one is MSI, medium scale integration. It consists of 100 to 10,000 of transistors in your on an IC, that is your medium scale integration. The next one is large scale integration. It consists of more than 10,000 transistors on an IC. Next one is VLSI, very large scale integrated circuit. It consists of more than 1 million number of transistors. Means an IC doesn't contains only transistors. With this transistors you will have all the different active and passive components like this resistors, capacitors and inductors. With this you will have a clock circuits and your VDD supplies, ground supplies, and all these different components will be connected through an interconnection wires, or it will, if it is a breadboard, all these components are connected with a routing wires. If it is a PCB board, you will doing soldering with the help of one end of a component will be connected to the another end, like that soldering process will be done. So integration is nothing but major concentration will be present on a transistor count. With this transistor count you will have these kind of different components. Okay, now the next one is ultra large scale integration. It consists of 1 billion number of transistors on your an IC. Now these are the different levels of an integration process in your VLSI circuit. All these are different components of different transistors or of same voltage or a different voltage will be placed on a single IC or on a wafer or on a die. It's nothing but a chip. Okay. Now whenever VLSI circuit is nothing but a combination of all your analog circuits and digital circuits. Entire thing is your VLSI chip. It will have all your analog components and digital components together. Now whenever if you want to design one VLSI circuit, what are the three major criteria you want to check? The first one is area, power, speed. Area, it should be in very compact in size, very less area occupancy to be present. It should be in very flexible nature. It should be moved from one place to the another place. If you go on, area is increasing, your complexity wise increases and you can't move that particular IC or a design from one place to the another place. So the first major thing is your area to be very less. It's nothing but your circuit to be in very compact in size. The next one is power. Always the power consumption to be very less, the two in terms of nanowatts it to be present. If more power consumption is there, at that time it will have less flexibility in nature. So that's the reason we have to have a very less power consumption. The next one is if these two terms are proportional to this one, when these two are very less, automatically the speed to be very more, means the run time, execution time should be very more and very a very high speed process to be run in a single clock cycle. So your speed to be more. So area, power, speed. These are the three major criteria for your VLSI design circuit. Okay. Now we will see about ECAD. What is meant by an ECAD and what is the relation between ECAD and VLSI. ECAD is denoted as electronic computer aided design. Now, whatever the different components, those are nothing but hardware components which are placed on an IC to be described by using one of the tool or one of the language. Those are nothing but CAD tools, computer aided design tools. Those are nothing but all the electronic components which are placed on an IC to be described with the help of one of the tool on an software. That one is CAD tools. So for an example, like for an mechanical engineering department, they will have their own CAD tools for designing of an machineries or an engine circuits or whatever motors and everything. So like that for civil, they will have their own AutoCAD tools mainly for designing of construction purpose, or elevation purpose and everything. So whatever the major function of your CAD tool is, what are the different types of structures or the different types of components and everything to be designed and to be verified and to be tested with the help of this particular CAD tool. So here for your ECAD, so whatever the components which are placed on an VLSI circuits for whatever on an IC, all those electronic circuits will be designed with the help of an CAD tools. So this is about the general introduction of your ECAD and VLSI terminologies. Now let us see what you are going to study in this particular laboratory. What are the things will be present and how those things will be useful for you in your future. Now complete your lab session is classified into two cycles. The first one is cycle 1 and next one is cycle 2. And cycle 1 is mainly will be concentrating on your sequential circuits, combinational circuits. For an example, combinational circuits are nothing but your logic gates, decoders, multiplexers, encoders, demultiplexers. Such type of all those circuits will be analyzed and it will be designed and it will be tested and it will be verified. It will be verification is nothing. Verifying means according the truth table your waveform is executing, it is getting or not, will be checking. In the same wise for your sequential circuits like your flip-flops, registers, amplifiers, so all these type of circuits will be verified. So it's nothing but a same basics what you have studied in LST subject. Now here you will be using one of the language is nothing but a Verilog language. In that Verilog language, you by whatever the circuits which are present, all these circuits will be write a program with the help of a Verilog language. Verilog language means whatever your design file is nothing but whatever you will have in a functionality, boolean expression will be present. And the next one is a test bench file. In this test bench file you will be giving all your test cases and everything in your thing. So and by using a Verilog language you will be writing all these programs, and after writing a program all these things to be executed in a tool, right? That one is your Xilinx tool. Mainly this Xilinx tool will be targeted for an FPGA devices. FPGA is nothing but field programmable gate arrays. Okay, gate arrays. What is that? Nothing but your field programmable gate arrays, nothing but it consists of all your CPLD devices. CPLD is nothing but again complementary programmable logic devices. It consists of your PLAs, PALs and everything. So with this circuits, and you will have all your LAN cables, Ethernet cables, clocks, global clocks, whatever your all different types of cables. This particular, it is in a single FPGA board will be connected to your CPU. It will have an IP core. With this IP core all the different components for a different functionality will be present. So mainly the Xilinx tool, whatever your testing all these files, these will be targeted to your FPGA devices. Xilinx is one of the leading VLSI company mainly designed for an FPGA devices. So whenever your further sessions we will be seeing what is an FPGA, how that will be present and everything in detail. Okay, this is about your cycle 1. Cycle 1 is completely about your digital design circuits. All digital designs will be tested and it will be functioned and it will be verified according to the truth table or a Boolean equations or whatever your corner maps. That one is your cycle 1. Cycle 2 is completely about an analog design. Here all your circuits will be designed with the help of transistors. Those are nothing but your NMOS transistors or a PMOS transistors. With the help of these kind of transistors, you will be designing one of the circuits like an amplifier. Not amplifiers, even whatever all the circuits of a combinational and sequential circuits, all these circuits here you can draw with the help of transistors, and that tool is nothing but an Cadence Virtuosa tool. It's similar to your multi-sim. Okay, all the transistors, components, resistors, inductors, power supplies, grounds and everything with a symbol representation will be present. You will just drag and drop all those